Assalamualaikum. Hi guys. In this video, I will explain when do we use Arrhenius equation. So let's start. First, let's look at Arrhenius equation. So this is Arrhenius equation where K is the rate constant, A is Arrhenius constant, or it also refers to collision frequency factor, E exponential, EA activation energy, R is gas constant, and T is temperature. In this equation, it relates the relationship between the rate constant, activation energy, and temperature. This equation also explains that only activation energy and temperature can affect the value of rate constant. So previously you have learned about the factors that affect rate of reaction, such as concentration, pressure, and size of particle. Those are the factors that only affect the rate of reaction but not the rate constant. So this equation explains that the addition of catalyst will lower the value of activation energy. And when we change the temperature of the reaction, it can change the value of rate constant. In this equation, when activation energy is lowered by the addition of catalyst, the rate constant will increase. This is because the factor negative EA over RT will increase when we lower the activation energy. And when temperature increase, it will increase the rate constant. This is because the factor negative EA over RT will increase when we increase the temperature. From this equation, the value of R is 8.314 joule per mole per Kelvin. From this gas constant, it means that the activation energy must be in unit joule, or if you find the activation energy, the unit is in unit joule, not kilojoule. And from this gas constant also, the unit of temperature must be in unit Kelvin. So you have to double check all the units before you use this equation. To plot a graph, from the previous equation, you have to convert into this equation by adding ln on both sides, this side and this side. And after we arrange the equation, you will get this one. So from this equation, you will obtain a straight line graph where it obeys y equals to mx plus c. So from the graph, ln k is the y-axis, 1 over t is the x-axis, and the gradient is negative EA over R. So it means that you will get a negative slope graph. While the y-intercept is ln A. So the value of A can be only obtained from graph. It is not a constant with the same value. Sama ada kita boleh dapat daripada graph ataupun daripada data yang diberi. This is example 12 in your module. So usually for this type of question, you will be given the value of rate constant and temperature. So you have to check the unit of temperature because you have to make sure that the temperature must be in unit Kelvin. The table shows the value of rate constant for decomposition of hydrogen iodide. Using the data below, plot ln K versus 1/t. So this question is quite easy because it has mentioned kita nak plot apa versus apa. Biasanya soalan terus suruh determine activation energy. Okay, tapi kalau soalan dah beritahu ln K versus 1/t, so lebih senanglah kerja awak. So from this data, we can determine the activation energy from graph. So you have to plot using a graph paper so that we get accurate value for the gradient. So first you have to create a new table, put ln K values and put 1/t values in that table. So biasanya untuk PSPM buat table ni pun ada markah. Okay, then kita akan plot. So the y-axis is ln K, the x-axis is 1/t. So after you plot this graph, you will get a negative straight line graph with negative gradient. From the equation, ln K equals to negative EA over R 1/t plus ln A. So from here we know that we can find the value of activation energy from the gradient. Okay, so untuk straight line graph, usually you have to make sure you get a best line. It touches almost all points. Okay, selalunya kat situ ada markah lah untuk touches all points tu. So kita akan dapatkan the values of x1 and y1. Then find the values of x2 and y2. Then you find the gradient. So from the gradient, just substitute into this value here. So equals to negative EA over R. So R ni gas constant 8.314 tadilah. So finally you will get the answer in joule per mole first. Tapi soalan suruh convert kepada kilojoule per mole. So just divide with 1000. So you will get 185.9. So that's for example 12. Now I will show you the PSPM question 2013-2014. So kalau ikutkan soalan ni jarang keluar soalan graph untuk determine activation energy. So the following reaction is first order with respect to NO2 and zero order with respect to O2. So in table 1, the temperature is given in unit Kelvin and the value of rate constant is given. Write the rate law of this reaction and determine graphically. So graphically meaning that you have to use a graph paper. The activation energy in kilojoule per mole for the reaction. Okay, so untuk rate law ni senang aja lah. Okay, kita dah tahu dah the order of NO2 apa and the order of O2 apa. So kita akan dapatlah rate equals to K NO2 okay, to the power 1 and zero order with respect to O2. So O2 kuasa kosong, maksudnya 1 lah, tak payah tulis pun tak apa. So this is the rate law. For the next question, determine graphically. So first you have to create a new table, okay, and 1/t. Okay, so put all the data inside the table and you have to plot a graph ln K versus 1/t. So sama macam contoh tadi, awak dah plot data dalam graph. So awak akan dapat straight line graph with negative gradient. So kita akan dapatkanlah the value of gradient and the gradient nanti kita akan dapatlah the gradient is equals to negative EA over R. So kita boleh dapatlah the value of activation energy. So activation energy yang awak akan dapat kat sini nanti dalam unit joule per mole, sebab kat sini R dia 8.314 joule per mole per Kelvin. So you have to convert into kilojoule lah, sebab soalan minta dalam kilojoule. So itu untuk plotting graph. Next, to solve calculation problems. So kat sini biasanya awak akan diberi two rate constant at two different temperature. Then you have to determine the activation energy, ataupun mana-manalah, mungkin dia akan bagi activation energy, okay, one of the rate constant and two temperature, or any of them akan dibiarkan kosong. Okay, so soalan macam ni selalunya kita akan selesaikan bila melibatkan activation energy lah. So So ada dua version equation kat sini. Kalau K2 over K1, so negatif EA over R, dalam ni T2 minus T1 lah. Okey, tapi saya sarankan awak guna equation yang ni. Okay, sebab kita dah positifkan EA over R tu, kat dalam ni kita akan terbalikkan lah T1 minus T2. So please keep in mind, EA unit mesti dalam unit Joule, temperature mesti dalam unit Kelvin. Okay, rate constant tak kisah ya dalam unit apa pun. Now let's look at example 13. The decomposition of hydrogen iodide has rate constant 9.51 times 10 to the power negative 9. This is the temperature given. And this is the other rate constant for 600 Kelvin. So you have to find EA. So untuk elakkan kesilapan, awak assign lah which one is K2 and T2. So kalau ikut soalan ni, dia buat sini buat K2, sini T2. Kena elakkan tersilap letak So yang ni K1, this one is T1. Okay, so kita letak K2 kat atas, so T2 kita akan letak kat belakang lah. K1 kita letak kat bawah, T1 kita akan letak dekat depan. So finally, you will get the answer in joule per mole. Soalan tak diminta suruh tukar, so you can leave the answer in joule per mole, ataupun kalau nak tukar ke kilojoule per mole pun boleh. So that's all for Arrhenius equation. See you again. Bye.